Hello everyone and welcome to Handmade Heroes, show where we code a complete game live on stream. We are at a point where I think the only thing left on our to-do list before updating the art is I was going to do some particle system stuff. Because I really don't know how we actually want to structure those for the way that our game works at the moment. There's a number of kind of subtleties about it, specifically because we use a localized coordinate system for all of our stuff, and we want to have very large worlds and not have particle systems be simulating if they're not nearby and all sorts of things like that. So there's not really very much to say about particle systems like on Handmade Hero in terms of the core particle system aspect of it. I pretty much we took a 2-day break a long time ago where I just did particle systems because we kind of like randomly said, what should I do for 2 days in between some stuff we're doing, and we did particle systems. So those of you who have been following along have already kind of seen me talk about the general part of particle systems, the Eulerian Lagrangian stuff, and generally how they work. There's not a lot to them. They're pretty straightforward, and then it's just a question of how hardcore into physics do you want to go versus just hacking stuff, you know. So you can start to make your particle systems be relatively physically rigorous as you go, and then it starts getting more mathy, certainly, but in general, there really isn't a lot to the particle system part of it. It's really just how much actual physics you want to bring in is what determines mostly the complexity of the math you have to understand, but the actual particle systems part is not particularly complicated. It's just, hey, we've got a lot of points, they're moving around. That's about all there is to say. So really, most of the complexity for us is going to come in on the bookkeeping side of things, right? It's how do we know where the particle systems are that we want to simulate? How do we know when we want to simulate them? How do we make sure that when a particle system comes into view, it looks like somewhat proper? You know, if it's fog or a waterfall or whatever it is, how do we make sure you don't like see it start up? You know, I'm sure you've seen this happen in games before where you'll be like walking into an area and you can actually see like the waterfall start falling when you get close to it because it's like, hey, you got near enough to like trigger the particle system to start or whatever, but it was asleep before, so now you've kind of got this startup period. So there's a lot of stuff like that where, you know, it's not really central to the main part of the particle system, or understanding how to implement a basic particle system, or even an advanced particle system, the particle system part. But there's all of this kind of bookkeeping that is involved, and that's really the part that needs to kind of get hashed out. And I wish I could say that was a pun. I don't know that we're going to use any hash tables. Maybe we will, and then it will be a great pun. But if not, then not as good. So yeah, let me quickly on the Blackboard. I don't know that we're going to have a full Blackboard session today because I think a lot of this is going to kind of have to be discovery sorts of stuff. So let me just quickly say kind of what the issues are that we're facing here, and then I will sort of jump into the code and just maybe start to sketch things out a little bit today so that tomorrow we can start implementing the parts of it that we care about, right? Okay. So just to remind everyone of kind of what's going on here, we've got a virtual coordinate system, a sort of a localized coordinate system that we do our sim stuff in. So typically, you know, if we have something that, you know, looks kind of like this sort of a scenario where maybe we've got, let's say, we've got, you know, the hero is here, and this is a room or something, you know, and there's, you know, some walls around, but, you know, there's exits, you maybe north and south exits here, that sort of thing, that they could go through and whatever. They're looking at this particular thing. There's the simulation region. The simulation region probably comes out to about here, perhaps, so because there's rooms that are nearby. We allow those rooms to be simulated so that enemies who are maybe like in the room next to you might come in, or if were chasing you, they could follow you. Things like that are all sort of on the table. So, you know, in this scenario, the important thing to remember, because it's been a while since we implemented the basics of this stuff, is that we really don't have any notion of a world space beyond sort of the tile, like these sort of tile chunks that we have, and things are kind of relative to them. What that means is that if we wanted to have a particle system that's persistent, that particle system kind of has to be based around somewhere so that when it actually gets rendered, there's some way which we know where it is relative to the camera, right? Because you remember what happened, like, you know, we've got like a tree or something, that tree is packed into a chunk, and we know where the chunk is relative to the camera, so the way we know where the tree is that when we unpack it, we know it's there, right? And particle systems are going to have to do something similar. The particle systems are going to have to get unpacked in a similar fashion, where we unpack a particle system when we know that it's within our view or our simulation region and we simulate it. We need to do something similar, I think, for the particle systems. Now, the thing with the particle systems is that unlike our entities, which we could pack down to fairly small and probably will eventually, one of the sort of ideas behind the entity system I was doing was to kind of do a streaming entity system, right, where you could pack entities down to small, only the part you actually needed to remember about them, and then you blew them out into bigger entities when you were processing on them so that you wouldn't have to constantly do loops through property lists or things like this. But particle systems are not that way. The state of a particle system cannot be represented in a small amount of space if it is dynamic, right? Now, there are other things that we could consider here, and let me just quickly tell you how that goes. The way that I have implemented particle systems in the past on previous projects, and this is also how particle systems worked in Braid, is that they're actually deterministic and based entirely on a single t value. So, for example, you know, if you have particles that are kind of shooting out from a point like an explosion, you actually, just to generate the particle system, you actually redo the entire particle system every time by using a random seed and a t-value that just says, okay, I generate all the random particles every time, I move them however far they would have gone in the time step t, and that's how I do my explosion, right? So then all I have to remember is like the location of the explosion, the t-value of the explosion, and any time I can recreate that explosion. Now, the problem with this is it means that you fundamentally can't have very interesting particle systems. And what I mean by that is that all of the particle systems have to be completely based on t, which means that the particles themselves can't really interact with anything that might be moving, right? That might be transient. For example, if I wanted to make my explosion bend around objects that were in the way, it could not do that if it was strictly based on t. And the reason that it couldn't do that if it was strictly based on t is because as things move in the locus of the explosion, like let's say we've got something that's moving this way, right? Then the particles, as they explode, should only be moving around this thing when they get here, right? And as this thing moves over here, if the thing was entirely regenerated every time, the particles that should have hit this thing when it was here will no longer even know that it's there, and they'll jump to a different location discontinuously, right, as this thing moves. So you end up in this situation where unless the entire thing is a function of t, which it can't really be because this could be a player with player input and stuff like that, and so then you have to record the player input and simulate where the things would have been as the t. That means you have to individually step the objects, and quickly this whole scheme like blows up, right? So f of t particles, like particle systems that work like this, where you just input a single t and you're done, they just can't be very physically active. They can't interact with things in a very detailed fashion, and it's a big limitation for them. So while we could do that on Handmade Hero, and maybe we will do that on Handmade Hero in certain circumstances, right? Like we could imagine, oh, if we just have a particle system for a little torch that flickers or something, you know, that's something that an f of t particle system could do just fine. If we don't need a lot of dynamism from things moving through the torch, or who knows what happens to this torch, then, you know, it's not that big a deal. But assuming that we do care more about what happens to those particle systems, then it just isn't very interesting. Even in the torch case, if we want things to smoothly animate through it and like cause poofs and things like this to happen to that torch, when something like shoots through it, stuff like that, you just end up in a circumstance where FFT particle systems are not going to be particularly good. What that means is I think we want fundamentally an F of delta T particle system, right? Which is to say that each frame we would input the amount of time that has elapsed, and we will simulate all of our particles forward, and while we are simulating them forward, we can choose to do things like intersection testing and allow them to respond to dynamic objects in the scene if we so desire, right? So a traditional physics update step for the particle systems. This is how particle systems are often done. This is probably the more common way, in fact, that they're done. FFT is probably less common, where you know, just being able to dial a particle system in entirely from just a single time value. Okay. So the problem with the FFT system from our perspective here is that particle systems might be quite giant. For example, let's suppose we want 4,000 or 4,096 particles in a particle system, which isn't even that many particles for a particle system. Actually, GPUs today are very fast. You can push a lot of particles on a GPU. So a single particle system of 4,000 particles, not particularly much. But if you think about how much that would have to that would take for storage, just that one particle system at 4,096 particles, if you imagined we were storing even just, say, 16 or 32 bytes worth of data, it quickly gets, oh, that's great. It quickly gets quite large, right? You're starting to talk about 128K, 256K per particle system that then has to be persistent, right? It has to be persistent in the world. And if we are having very giant worlds, we don't generally want, if there's like 4 or 5 particle systems a stream, or a screen or something like that, that are now getting saved, that's half a megabyte per room. If we have even conservatively 500 rooms, like, okay, you can just sort of see this start to multiply out here. Now we're talking about a quarter of a gigabyte just to store our particle systems. It's just not particularly attractive as an option, right? Furthermore, there's all this traffic of storing it out, and who knows what else, right? It would break our chunk system, right? Because our chunk system is based on streaming things in and out of it. Now you're streaming way too much in and out of it, so blah, 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 blah. So, honestly, it just doesn't seem like a particularly compelling idea to me to store these particle systems in the world as persistent things, especially because they don't really matter to the gameplay in that way, right? A typical particle system is there for special effects, and it, to the degree which it does affect the gameplay, usually that is at a more granular level than the individual particles themselves. For example, maybe I do have a flame on a torch that lights things on fire. Typically, I don't test every particle to see if something hits it to light on fire, right? That could get prohibitively expensive anyway and might be too hard to simulate, right? So typically what I would do instead is I'll just test the region of that thing and say if something's in this region, then I light it on fire, and maybe add some poofing to make the particles go out. But I don't test every single particle, right, on that thing necessarily. You know what I'm saying? And so, I don't really need them for gameplay purposes. I don't have to know where every particle was. So if we forgot, where those particles were, that wouldn't actually do anything bad to the game. All we have to do is make sure that when the player is actually looking at the particles and they're inside, like the sim region, let's say, that they stay consistent, because we want them to look consistent, like they're a part of the world and not all weird, jumpy, erratic. So obviously we want them to look consistent while you're looking at them. But after you're no longer looking at them, we really don't care what happens to them. We just care that when they come on the screen, stay on the screen, and leave the screen, for that duration of time, it always looked right, and it looked plausible and believable, like it was a particle system that had been, something that had been simulating the entire time. And so for our purposes, what I would propose, and I think the first sort of route that I'm going to take, and we'll see how it works out, is I'm going to say that what we want is sort of like cached particles, right? And I think this is a fairly common technique. I mean, I couldn't tell you offhand how many people do particle systems like this, but I suspect it's a reasonable number. We're certainly not the first. We certainly won't be the last to attempt something like this. And the idea here is just that, well, okay, if we already have the notion of a simulation region, what if we just said we've got room for some number of particle systems, right? So let's say we go, okay, what's our biggest particle? You know, how many particles do we want to simulate at maximum for any particle system? You know, maybe it's 64K particles, let's say. How many particle systems do we want to simulate at any one time at maximum? Okay, maybe it's 64 particles or something like this. And maybe we just say, okay, that's the number of particle systems that there are ever, right? And then what we do is when we unpack a particle system, we use its unique ID to look up into a particle cache of 64 of these to see if we have a match. And if we have a match, then it just simulates that particle system. If we don't have a match, we evict the oldest thing in that system, like whatever the least recently used particle system was, we evict it and reinitialize this one in its place, right? So as things move into the sim region that are particle systems, this happens, right? And as things leave the region, well, they still stay in the cache potentially for some time, depending on how many other particle systems are actively being used inside here. But eventually, they will get reclaimed when there are 64 new particle systems that have come through the simulation region since it left, right? Or rather, since it came on, I should say. And so we can also prioritize these if we think that 64 is not enough to handle all cases, and maybe there will, we could say that there will never be more than 64 particle systems on one screen at a time, but maybe when you get up to 9 screens, there could be. We could also do sort of a 2-level priority scheme where we could have particle systems that are actively on the screen are prioritized higher, or maybe just in general we could say that the further you are away from the camera, the less priority you get in terms of eviction. So, it might not be strictly least recently used. It may be more like distance from camera. And so if you are closer to the camera, we will preserve you at the expense of someone far away from the camera in the event that all of the particles have been touched this frame or last frame, and so we don't have one that we know we can throw away that isn't going to be touched, right? So yeah, what the eviction scheme would be is probably something that's a little bit more specific there, but we could also just say we'll just always set this number high enough so that it can cache it, right? Memory, we have a lot of it. And hey, computers are fast, so maybe just let the user have some fun with that CPU they paid for, and let it just simulate a lot of particle systems. We'll see if it bogs things down. If it does, we'll address it in some other way. We'll SIMD it, we'll do whatever. Okay. So I think that's basically it. That's really all I wanted to say about the particle systems. Hopefully you understand roughly what I'm talking about in terms of the motivation there. And now you can kind of see roughly what I mean in terms of a cached particle system or a cache-based particle system, where we're talking about, not really having a permanent home for any individual particle system, rather just using a cache to say when they're around, when they're not, they kind of disappear from existence. Then all we do is into our game permanent store, we do have entities that themselves just mark the fact that there is a particle system somewhere and say what kind of particle system it is. And then that is all that we actually keep in the permanent storage. So hopefully that makes some sense to you, and you can sort of see where I'm going with that. I'm going to hop over to the code. I don't think there's anything else constructive to say on the Blackboard But that is what I'm going to start typing in, is just a thing that kind of does that caching and allows the particle systems to come in and out of being. Then what we'll do tomorrow, I think, because I've got about, I don't know, a half an hour or so, maybe a little more. I've got about a half hour to implement that. Then what we'll do tomorrow is start to talk about, okay, let's make some particle systems and get them kind of functioning so that we can maybe actually have some entities that are particle systems, right? And so this way we can have entities, maybe we'll do some stuff, like I said, like a little like fire that burns. And then I'd like to do some that are a little more complicated, like maybe we'll do some ground level fog or something like this. And we'll see whether we want to have sort of the Eulerian sort of occupancy stuff that I kind of talked about before. We may want to put in some of that as well. I'm a little nervous about Eulerian occupancy stuff, only because I don't really know how well that's going to work in practice for things like ground fog. I don't know. I'll have to see what we think. So we're kind of going to have to play around with it. And see what we think about stuff like that. But point being, we'll play around with some of those, and by playing around with some different kinds of particle systems, we can then sort of ask ourselves, what actually are the things we want these cache particle systems to have in them in terms of capabilities, and then we can build it out from there. Because the cache will work the same way regardless, so I can implement that today. But then in terms of what is actually in those particle systems and how we sort of, what parameters we expose to the game model to sort of like be able to create interesting particle systems without having to go like re-implement everything every time, will depend on sort of us implementing some kind of example particle systems that we think are kind of like the ones we might want, and sort of seeing, okay, what kind of support do we need here? And of course, it's never the end of the world, since these things are just kind of storing a bunch of data. The cache we can always extend to add new types of particle systems if we misjudge, but we want to sort of put some in there to begin with that we can use as we sort of do basic stuff in the game, so we can kind of see how the particles look and use them for nice effects and that sort of thing. It looks like I don't have a command prompt open, so I'm going to go ahead and open one up. Today is day 336, so you want to start with day 335 source code if you're trying to follow the changes that I'm about to make right now. So compiling the game, everything I believe we left in a kind of a relatively done state here in terms of stuff we had been working on. So yeah, there's my little hero hopping around and having a grand old time. And off we go. So let's go ahead and take a look at the sim region stuff. My belief is that this, if you take a look at the way the sim region stuff, these sim regions are kind of meant to like come and go very sort of spontaneously throughout the run of the program. And so the sim region itself is not really the right place to put this cache. And the reason that it's not the right place to put this cache is because, again, a sim region is supposed to be something that just pops up, simulates a region, and then goes away. And so it can't store data from frame to frame. That's not really what it does. And I don't want to make it do that, because I want to be able to use it in ways where I just kind of like create a sim region to simulate something and then have it finish and just be done with it. It's supposed to be transient that way and multi-threadable in that way. So what I need is the cache of particle systems to be something that's sort of a separate thing, right? So there should be like a separate channel, if you will, of particle system cache information. And when we run a sim region, if we give it a particle system cache, then when it unpacks entities, it will go ahead and look in the cache and update the cache. If we don't give it a cache, it won't. Because remember, the sim region is one of those things that we may want to use, and we kind of talked about this a little bit the other day. We may want to use it to simulate areas of the game that the player can't see, where there are other things going on that we want to know the outcome of, so that when the player does get there, they will see the results of them have happened. So if we want that capability, we don't want to require those areas to have their particle system simulated, because that will take a bunch of extra CPU time that we didn't really need to spend, because nobody can see those particle systems. And so the only thing that we want to simulate about particle systems in that case is the gameplay logic part, which is something I want to keep in the entities themselves. So we want to make sure to segregate this, and as I'm doing it, I'm going to keep it very rigidly segmented in that sense. I want to make sure that the sim region just uses a particle cache. It doesn't sort of contain and require a particle cache. And so that's why I'm proceeding in the way that I am. So if we go in here to Handmade Heroes code here, I want to just copy, I want to get a starter file here for like Handmade particles, like so. I still haven't, I need to someday write forcoder, my custom forcoder. I've never written the thing that like creates a new file and puts my header in it. I was too lazy for some reason. So I just always copy an existing file that has the header in it. Real high rent, I know. So I'm going to create a thing for particles here. And what I'd like to do is I'd like to start making that cache. And I want to, because I kind of know what I want the usage code to be here, I'm going to write the usage code first. I always used to say always write the usage code first. But after kind of like, I think it was Alan kind of asked me some good questions about it, I came to the realization that really what I do is I write the side I know first. If I know exactly how the implementation should work but don't know what the API looks like, I use kind of a compression style scheme to get there. And if I know that I want the API to look a certain way, or I believe I can determine it, but I don't know exactly what the implementation should look like, then I go the other direction. And so I definitely have different modes that I go in depending on what I know, right? And it's worth noting that the hardest problems are when you know neither side. When you neither know the efficient way to write the actual code, nor do you know what its API should look like, then you're kind of in this really nasty no man's land. And it's kind of this problem, it's a lot like boundary value problems in mathematics, where you know things sort of, where you have to kind of have these guesses about how to get from one place to another when you don't really know very much about anything that's in between them, right? And so those are kind of very hard problems to solve all across the board. But in this case, I pretty much do know, I think, what I want at least that cache part to look like. So I'm going to start with that and let that kind of build. So what I'm imagining here, right, is that when I unpack these entities, so here's an example of like unpacking these entities, right? We go through and we stream out the entities and we put those entities in there. And then what I want to do is say, like, okay, when we have an entity source, I'm kind of wondering, why is there an if on the source there? Does anyone know? Can the source ever be 0? Like, look, I just got it out of, like, what? That doesn't make any sense. Oops. How could that source ever be 0? Oh, wait, no, it can be. It's a pointer. Never mind. Wow. I'm out to lunch today. It can be. Right? These entity datas, I guess, could keep it in there. Plus entity index. Although, no. No, I'm not out to lunch. It can't be. Right? I mean, that's just... they're all in the block. If there wasn't an entity there, it wouldn't have ever gotten packed. So I don't know. Yeah, that's just dumb. I don't know why that was there. Nobody knows. Anyway, doesn't matter. So anyway, when we go ahead and do the entity overlaps rectangle test, and we're going to mark this thing as active, you can see that we do a brain thing where we add the brain in. What I'd also like to do is say, okay, let's also say if the dest, particle something, if it's a particle system, then we would want to get or create particle system kind of thing. And we'd want to pass this particle thing, probably. Although probably the ID for the entity might just be okay, because we have these entity ID things here where we can say, like, this entity, it has a unique ID. So really, I guess I can just use this. So I just need to do something where I say, okay, if my particle system, if this entity has a particle system, whatever that means, then I want to get or create one with the particle system manager or whatever. So we have a particle cache, and we'd say if we had the particle cache, and this is the thing that wants a particle system, then we would ask the particle cache, to get one for us, right? And I guess I could just say get particle system because, well, no, I'll do get or create. And I'll pass a true value there that's like I want to create it. So in case we want to just do a test where we say, hey, do you have one here? Then off we would go, right? Now, I don't know that we need to pass anything else. I think that might be all we need to pass. And so when we do get or create particle system here, that will generate the particle system. Now, presumably the particle system probably also wants to know the information about its location. Because like I said, it's kind of got to do its sim stuff, right? And so it needs to know like where that particle would actually be. So probably in addition to that, I guess, and you know what, I could just pass the whole entity, I suppose. So probably what I'd do is say, all right, let's pass the entity. I guess I'd pass the dest entity here. So instead of the idea, say, here's the whole entity, create the particle system for this thing. And the dest p, it could look up directly, like now it knows the location of this particle system relative to the camera. It can just go ahead and do its thing, right? Okay, so I think that's probably all we really need from the first part of the API is to make sure that we do the get or create particle system part. We don't actually need the particle system to be returned here because we don't care, right? I don't think there's fundamentally anything that we need to actually do about it yet. We could, I mean, in general, I guess we would say for passing this entity, I suppose we could make this a little bit more generic. Maybe... I mean, I guess we could make this a little bit more generic. We could do something like this. Say, hey, all right, here's the ID. Here's like the data for the particle system in case you need to create it. And we could do something more like, like that. So, if this thing had a particle system in it, then, it gets recreated or whatever from the base data that it needs or blah, 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 blah. I have no idea. Right. You get the idea. Okay, so suppose we did something like this. Then we know that our particle cache would have all of the particles in it that had actually been activated at that point, right? And off they would go. Now, when I do get or create particle system, I suppose I should also kind of say something more like... that this touches the particle system as well. So I could do something like touch particle system. So I don't know what I'd do here. Particle system. Like that. I'll just say, okay, we'll touch the particle system as well. And the reason that that's important, I think, is because if we have this particle system cache, I don't know that we want to always require all of our entity code to be intelligent about shutting down the particle systems when necessary. And what I mean by that is just that, okay, so in a cache scheme, you typically have a situation where something happens like, all right, take since I already gave the example of a torch, we've got a torch, and it's on fire, right? Yay. So the flames are burning around, burning flames, and the burning flames are just like a particle system that we've created here. But later on, somebody destroys the torch, or I don't know what, right? Well, maybe, the person who wrote that code to destroy the torch, does something with the particle system to make it do like a poof thing and make smoke. In which case, it's fine. And in that case, they could mark the particle system by saying this particle system doesn't need to be touched anymore. It's on its own cleanup scheme or whatever, right? But let's say that nobody does that. Then, in that case, we have a bug where when the torch goes away, the flame will keep being there. And it'll be there till the user walks off and leaves the torch behind, then comes back. And then the flame won't be there anymore because it will have gone out of the cache, hopefully, at that point, right? And so what typically I like to do in these sorts of cache-based schemes, incidentally, this is the same way that I do things like that in IAM-GUI style systems, is I like to have a notion of when I have touched things on a frame. So if I haven't told you anything about this torch on this frame, that's a clue to the cache system that whatever the thing was that was causing this to exist is now gone or is not active at the moment anymore. And so you should start to take action to clean it up in a default way. So for example, thing we could do with particle systems is just fade them out at that point, right? And that means that, yeah, okay, is it as good as if every piece of code that ever used particle systems always was able to perfectly shut it down in some nice way where it made the particle system do some animation that made sense and then cleaned up or whatever? Yes. Do I want to be do I want to be paranoid enough to make sure that that happens in 100% of all cases in a game that's going to be as wacky as the simulation in this game? No. So what I'd rather do is design the system so that the failure case of not doing that doesn't really create much of a visible bug. It's a slight bug, it's like not as nice as before, but it's not an obvious, in-your-face, ridiculously stupid thing like a flame that keeps on burning arbitrarily long even though its torch is gone, right? So that's kind of more what I mean by that. And so I just also wanted to include that concept here where I was saying, like, I'm going to want to get the particle system. I'm going to want to say that it's touched now, like whoever this person is using it. So, you know, consider it an active particle system, basically. And then you can fall out the code path and we don't have to worry about it anymore. So now we've got our nsim, right? And the nsim doesn't need to really do anything because during the end of the simulation, normally we would clean up these particle systems, but we want them to persist. So we're specifically not going to get rid of anything that we may have done with the process. They're supposed to persist. So don't really need to do anything there. All we need now is a place where these particle systems can be advanced, right? And so what I would say about that is inside our entity system, you know, what we could do is we could advance these when we simulate the entity, or we could have the particle system simulate on their own. At the moment, I guess I'll go with entity. I'm not sure why I wouldn't, but it's hard to say. Yeah, it's hard to say. So here's what I'll do. I'll just say that this gets unpacked. And so this will be part of our unpack process. So I will say, like, it goes from the source, and it's not necessarily in the dest. So there's a, you know, a particle spec here. And then here in the dest, we'll unpack it and record the active particle system and do it like so. I will also test the active, well, I guess I don't need to. I'll do that inside touch. And so that way I can say it's an unpack. And so basically what we do is we have the particle spec. It gets unpacked essentially to the active particle system here, which is something that will track in the entity structure. And so then when we come around and it's time to simulate our entities, what we can do is during the sim, right? So when we're in here, we can simulate the particle system. So we can do like an advanced particle system. Or, you know, update and render particle system. Something like this. So we've got that, and that, of course, will need to take a bunch of things here. But first and foremost, it would have to take the active particle system. It would also need to take, presumably, the particle cache. I also don't know, do we know what our DT is? Where's our DT at? Yeah. So we also need our time step, and we've got it, so that's good. We'll need our render information. But other than that, I don't know how much more we would really need. That's basically what we're looking at so far. Yeah. So now we kind of are starting to see the API take shape a little bit. We have not initialized this particle cache, and we don't know where it comes from, but it's a good bet that since this is something that only happens when you're looking at the world, it seems like the kind of thing that would probably be stored with the world or the world mode, probably the world in this case, but I don't know. It's a tough call because really it could be argued that it's part of the world mode because it's something that's purely visual. But we could also say that it's part of the world in the sense that if we had different modes looking at the same world, that they would, so 6 of one, half dozen of the other. I'm not going to worry about that too much because we can move it back and forth pretty freely, and it doesn't really matter too much to us. So I suspect the easiest thing to do here would be to just put it on the world. I don't see a way to get the world here, though. So I guess, it's just world mode world, if I remember correctly. But let me take a look at how much sense this makes. So we've got sort of the chunk cache here, and the chunk cache stores all that stuff inside this world. Does it make sense to store the particle cache here? I'm not sure. One of the things that makes that a little bit odd is you can see that really what's stored in the world is persistent data. So maybe that makes a little bit more of an argument against that. I'm not 100% sure how I feel about it one way or the other, but you can kind of see why I'm a little hesitant there. I'm just not 100%. I think I'm going to go ahead and put it in the world mode. I think I'm going to put it in the world mode. So I'm going to say that the particle cache comes from the world mode, and then I think we can get things started here. So let's take a look at the particles side of things here. I know that there's going to have to be some way of initializing this thing. I guess I don't care about that quite yet. Where's the rest of my stuff? Here it is. So I know I'm going to have one of these. And I know what it takes. So this is a active particle system. We just call it a particle system. We have the DT. And we have the render group. So we know we've got those. Inside sim region, we know we've got these two. And we know that this is going to take a particle. This is going to return a particle system. And we also know what it takes. There's the cache. There's the ID. And I don't really know if the ID values make sense to use entity IDs specifically. I guess I don't really know. It might make more sense to just translate it over to a U32, but for now, let's just use entity ID. That's what they're always going to be, I think. So we'll just leave it that way. And then we'll say particle spec, and then a create if not found. And then we've got our particle system. Here. Not a great typing day. And then we've got our desire to touch this. We want to touch it. And so then we need something here for that. So yeah, so I think that's mostly what we need there. And I guess now that I'm looking at the structure of this code, I can see that actually having the entities render the particle systems one at a time, I don't like. And the reason I don't like it is it doesn't allow fading out things past the point where they've been destroyed or something like that. Because if an entity gets destroyed, it won't be able to render its particle system anymore. So I think what I'd rather do is use sort of the, I kind of went back and forth. I think I can see from looking at the code there that I don't want this at all. That's not the way I want to do it. When we do update and render entities, I'm going to want to basically take update and render entities here and say, well, after you update and render the entities or whatever, that's when I want you to update and render the particle systems as well, and update them all, please. I'm not going to tell you which one of these to do because you're going to do them all. And that way you can do ones even that don't have any entity associated with them anymore. So you can have particle systems that have had their entity sort of deleted or gone away, and that won't actually affect anything for any practical matter. So if we do update and render particle systems, now we could do it like this. And here there'll be a for I loop where we kind of go through, all of our particle systems or whatever, right? And probably that looks more like this. And the particle system is here. And so, oops, meant to move that, delete it. So yeah, when we update and render the particle systems, we're going to go through all the ones that we actually have. Oops, forgot a closing parentheses. When we update and render the particle systems, we'll go through all the particle systems. When we touch them, we'll make sure that they're marked for the particular frame having actually existed. This should not be taking a spec, though. This should be taking a particle system. Yeah, and so that was just a wrongness. And that starts to look pretty reasonable to me. So here we go with particle system and particle cache. And, maybe we just say that there's particle systems, and there's 64 because I think that's what I said. And I don't remember what I don't really want that. I probably want these to be, SOA style things. So, it's probably pound define max particle count. And that's, whatever it is. And so then we just have something like this. And so we'll probably, while we do the particle systems here, we'll probably want to start bringing in some SIMD to the party here. And so we'll probably want to make this a little bit not like what I'm typing in right now. But we'll probably have something like this. I don't know exactly what. We'll probably want something that kind of looks like this, but we will want to be a little bit more... we'll want to make sure those are SIMD aligned and other sorts of things like this, so that they won't quite look like that, but something to that effect. So we'll have these guys, we'll have them in our particle system, and off we will go. And then in these particle systems, in addition to all of our arrays and such, we'll need some kind of a preamble that's like, oh, hey, yeah, there's an entity ID here, that's the ID of the particle system. And we'll eventually need something like the number of frames since it's been touched, something like this. And, we'll do more, we'll do something smarter with this as we go. When we touch a particle system, maybe we just say, okay, frames since touched equals 0, and maybe that's all there is to it for now. Maybe we'll move them up in a list or a heap or something in the future. But then, in here, when we've got the sort of loop through of the systems, we'll do something like this, so that, every time through, we sort of increment that touch amount. And so then when we do get or create particle system, what we can do is when we loop through to look to see if we've got a match, we can also see who the oldest particle system is, and then we can replace that particle system, right? Now there's a caveat here, which is that we don't really know if we've replaced a particle system till after. But what's interesting about that is that, I guess, if we're not going to have them be simulated, we don't really need to have this stored on the entity. So we can just say now that, we grab that particle system, and then, we do the touch up for it, and off we go, right? So anyway, so if that's the case, then we can sort of see how we would at least do the beginnings of the implementation here. All we would really have to do, and it's a little inefficient, but who knows, if we're only searching through 64 of these, it might be hard to make it that much more efficient at all. So I'm not sure. Like a linear scan of 64 entries may actually be the best. In fact, we could just plan for that up front and say, hey, guess what? There's just one array of those, and we look through them, right? And you can see, like, I didn't really, I kind of wanted to move that outside of there because I didn't want to have to do, when looking through the IDs, I didn't want to waste cache. All of these IDs, if there were 64, don't know why I'm going off on this right now, but just to sort of tell you why I just did what I did. We know that it's 4 bytes for an entity ID, right? So 4 bytes times 64 particle systems is 256 bytes total. If a cache line is 64 bytes wide, that's 4 cache lines that have to get loaded in order to check to see whether we have this particle system. Now, 4 cache lines being loaded is very cheap. And so, scanning those is going to be real quick. Now, if, on the other hand, we stored it in the top of the particle system, so if I did what I was saying before, now what we know is these particle systems are huge. So there's going to be no sharing of this because this will sort of take up the rest of the cache line that this sits in. So then what will happen is we'll say, well, if there were 64 particle systems, there's actually 64 cache lines that need to be read. So it's actually 16 times more cache lines that would have to be read into the processor in order to know whether or not a particular particle system exists there or not. And so, it makes more sense for us to say, let's minimize the number of cache lines that have to come in on that. We could do that a little bit more and say, like, particle system info, say, okay, these 2 things are the things that participate in the scan, right? And so we've got the info here, and then the actual systems themselves are separate. Okay. So just thinking out loud seems like a reasonable thing to do. So if we were to do that, then inside the particle part of this, right, what we would say is, like, still loop through the systems, but instead make it the system infos. And we just want to check those, right? So we would say, okay, the system infos ID, if the ID equals that one, then great, we're done. Our result is just whatever the system is that corresponds to that one. Right? There's our result. And we can stop looking now. But otherwise, we need to find the oldest one. So we would do, like, min frames since touched. And that would be, like, U32 maximum. Do we not have a U32 maximum? Somehow? It looks like we do not have a U32 maximum. Yeah, so now we have to do 1 billion. I guess we could just do this. For 4 billion in binary. Anyway, so yeah, if we start out assuming that the max, there's the maximum there, then what we can do is say, all right, if the min frame since touched is greater than whatever this system infos frame since touched is, then we want to grab it and remember this index, right? So we would do that, right? So essentially we're saying, like, hey, we want to go ahead and track which one is which here, which one has been kind of the oldest. And then when we fall out, we could just say, and I probably want to do it this way, or maybe just call this replace. We'll take replace. So if we come down here and we say we didn't find one, we just use the one that we're going to replace. And now we'll have to initialize the particle system. And we could actually do that, init particle system, and say, okay, init the result particle system, init it with this spec, right? And this ID. Something like that. And so in here, we would just have another call, which is whatever needs to happen to get a particle system started, which we won't really know what that is until we actually start writing some, right? But we'll find out soon enough. So here's the particle system, here's the entity ID, and here's the spec that we will use to actually implement it, right? And for the moment, particle spec is just going to be, empty. We don't know what it is. But we'll get to that later. Okay, so now what we need to do is actually sort of fill in some of these things that are missing. And I've got I think I've got about 3 minutes left. I think I didn't start till 20 after instead of 15 after. So I'm just going to take those 3 minutes to just tidy up some of this, and then we'll be done. Now, I said that during Begin Sim, I wanted to make this optional. So I want to basically say that you can pass a particle cache if you want to, but you do not have to pass one. And I also need to include these things because I haven't included them yet. And so if I go to handmade.h, oops, that's not handmade.h. Oh, there we go. What I want to do is include the particle systems. So now we've got them. And now we just need to flesh out and I should probably also, before I forget, include them here. I'm putting them above the sim region so we can kind of, yeah. Oops. So there, I think we're pretty good to go. I don't know why I called it particle cache spelled all the way out when that's kind of a waste of time. There we go. How do we compare two entity IDs? Presumably, there's already a thing for this, right? I mean, wouldn't there be something? Looks like is equal only happens for these guys, and it looks like it also kind of short circuits that test of dot value. Yeah, like this is kind of that test right there. So I feel like I kind of want to start using one of these, like is equal entity ID A, entity ID B. Result is A dot value equals B dot value. I think that makes me happier as a person. So I can do are equal or is equal. And be good. All right. So frame since touch is not... Okay, so yeah, that actually does pose an interesting problem, which I guess I don't really know if I care about solving. So I think what I'd probably do is say, we probably want people to be able to use this pointer. So I'm just going to use like an index here, which is just the system minus the particle cache systems. So I'm just going to say that's the offset, right? And so then if I want the info, I know I can just do particle system info equals particle cache infos So yeah. Conversion from inst4, yes. Don't worry, there will not be that many particle systems. And I think this was actually system infos. So when we go ahead and do these, then in this case, when we're looping through both of them, we only do this loop once, so I don't really care about how accessing is efficient here. So I will just say we access both of them, and I will increment the frame since touch there. So I think now we're just down to the entity storage stuff, I would suspect. It looks like function does not take 3 arguments. That's just because the particle cache isn't there, or what is the problem there? Particle spec, right. So we need to get particle spec in there. Particle cache is not a member of game mode world. So we just now are down to just the bookkeeping. So if we come around to entity, what we should be able to do is include a thing in here. So we should do like has particle system, and we should be able to do particle spec, particle system spec, or is it just particle spec? It is particle spec. And that information can be stored there. Particle spec as part of entity, I guess that would have to sort of jump up a little bit in priority there. The particles would have to actually be up here. That makes sense. Actually, but the problem with that is that entity ID isn't there. That's unfortunate. Entity ID is kind of a little too primal at that point. And there's no way to really organize those. There's no way to really forward declare them because they're actually included in the particle system info. So I kind of want entity ID to be moved up a little bit in terms of its thing there. How is the brain not use entity IDs? I guess because it's only runtime, so it doesn't need them. Interesting. So I want to go ahead and move those entity IDs up a little bit in terms of their precedence here in the include order, because they're kind of like things that are a little bit more used by everybody, if that makes sense. Okay, so then in here I can say that I want particles to be above the entity, which has that structure there. At this point, I'm just down to the world mode not having a particle cache in it, because now we actually do have the particle cache to pass here. And so all I really need to do is have the world mode, inside the world mode, have that particle cache present. So I'm going to put it down here at the moment, and these particle cells will go away because those were from our old experiments with particle systems. And so all we need to do is create one of these. I guess this can actually be sort of just created in line with the game mode world if we want it to. But it's kind of big, so I may want it to be off on its own. So I think what I may do is say that in game mode world, when things are getting sort of initialized in here, what I may do is say, okay, once we sort of do all this initialization, I'm going to also initialize those particle systems. So I'm going to say world mode particle cache equals push struct particle cache. And I don't really want it to clear, so I think we want to do that, right? And in terms of where we want this to go, we just want this to be in our sort of transient storage, right? Like whatever we're doing as far as our transient state here, we would want that arena. So I believe we would just say Tran arena, because we don't care what happens to these things. They don't get like saved and restored or anything like that, so they're not going to be in anything that's supposed to be there. Yeah, that needs an ampersand on it, but other than that, I think we're in good shape. Which function are we in? Update and render world. So yeah, in here we just need the world. So I don't know why this does world mode arrow world when that's right up here. I'm gonna assume it's safe to delete that and leave it that way. Yeah, and I think that's it. I don't think there's anything else we need to do. Now, this will not do anything other than crash if we mess something up, but, you know, like so. But that's pretty much all we actually needed to do there, I think. But yeah, not great there. That was not stellar, to say the least. But that's all the infrastructure that we need for the basic particle cache, I think. We've got a couple of loose ends to tie up there other than the debugging, which we can do tomorrow. Although I'll do one as I'm thinking of it here. When we actually create one of these particle systems, we did pass a flag that says whether we want to create if not found. So we probably want to do a check there to say we won't actually replace the particle system in the case where, you know, it's not supposed to be done. Also, I would probably do this, say to make sure that the index is less than system infos. There we go. And I think that's about it. I'll check temporarily to make sure that the there isn't an obvious bug for me to fix before going any further. Update and render world mode, and sim. So I'm not 100% sure why we should have done anything particularly unusual there. I will say that this is supposed to be, at this point, these should be, well, no, those are actually fine, I guess. Yeah, those are all fine. I'm just going to double check and say, well, okay. I was thinking through what I might do there for debugging, but I also wanted to do, since I'm not clearing, I wanted to do a init particle cache. So again, also, before I forget, I'd like to do an init particle cache there so I can kind of do just clearing the parts I actually care about, because the particle system now is a very large block. I don't want to bother clearing the whole thing to 0. I mean, I could, but I just don't know that I want to do that. Especially because they'll have to be cleared when they sort of change hands anyway. Oh no, I've gone too far over time. All right, I really got to stop. Sorry, I just, you know how it is sometimes you're in the middle of coding something and you're like, well, I just need to finish these few other things. All right, so anyway, if I knit the particle cache, all I really wanted to do there was kind of go through these guys and set the infos to nothing. That's really all I wanted. Was there a null? No. All right. Well, so I guess I'm out of time, unfortunately. I would like to debug this because I'm sure this is not something particularly hard to debug, but I guess I'm out of time, so I'm not allowed to debug it. Looks like that's an entity that's been borked. I really want to debug this, though, is the thing. What if no one saw me debug it? What if they just couldn't tell that I was out of time and not supposed to be debugging it right now, and we just didn't tell them that. So first thing is first, I'm just going to go ahead and go like this. Also, I think I said I was going to accept nulls there. And now everything is running with the new code zeroed out. So next, I will say, well, okay, what if we do this? And what if we do this? Explosion. So this is clearly not an acceptable thing to be doing. Which, you know, I mean, what are you going to do? Sometimes you're just doing some unacceptable stuff. So we have system infos and systems. They both have particle systems count worth of things. So, you know, I should probably assert that. But the only thing that does anything is this operation right here. And so if this operation right here is what's happening, that means that this is being impolite, right? This is officially overwriting something, right? It's doing something inappropriate. And so the question is, how exactly could that be doing it? But at least now that we know that that is what's doing it, it should be relatively easy for us to go in and watch it do it, right? Like we should be able to see that happening. And yeah, so if we know we're only doing particle system counts worth of this thing, then it doesn't really seem like that should be something the same, but we must have messed up where we place it in memory or something similar, or who knows what. Yeah. I also guess I should double check. Well, no, I guess I don't. So let me take a look here. So what are we putting in the Tran arena? So I guess I will say that does look like the kind of thing where maybe I was being a little bit hasty there. Like, I don't know, if we're not really using the Tran arena for anything at the moment, then maybe I kind of am not, you know, I don't know if maybe that was not something that we're still using. I haven't looked at that policy in a while. But if it's being used for temporary memory only there, then maybe this should actually have been part of the permanent. But I don't really want to be part of the permanent, and I feel like in here, that should be allowed. And so let me take a quick check. Yeah, I mean, the assets are coming out of there and so on. So I feel like that's like should have been within the realm of legitimacy. So, you know, I don't really feel like that's should be something that's happening, but I'm almost certain that is what's happening. So I guess I just need to be a little bit more careful about that. But here you go. Where did my code go? So inside here, like I'm pretty sure that what I'm doing is, well, you know, I must be reclaiming this memory, which is not what I wanted to do. And so I'm going to just double check that I'm right about that. All right. That's in world mode. So what I want to do here is say, all right, let's jump down And we allocate the particle cache. And then I want to see the transient arena. And this is like what the size was supposed to be at that time, right? So when we come out of here, let's see what happens. We're inside the cutscene renderer, and then we switch up to running the world mode, which we just switched to. And here we come through there. We are then gonna begin temporary memory on the transient arena. So that got locked in properly. So I don't know why that would be a problem. That seems totally legitimate to me. To be completely honest with you. So it pushes on a sim region, right? And it's using the temporary arena, so that should have gotten bigger now. Of course, I can't really see it because Visual Studio just has no idea where it could possibly be. But it didn't. Why didn't it? All right, now I'm curious. So there's the size that we're passing on there. It fits, apparently. We will not clear it to 0. Oh, because I'm looking at the wrong variable. I was looking at size. I wanted used. Ignore everything I just said. Don't worry about it. So there's my used. And now, if I look at the correct value, it should go up. Right, so there we are with the memory where we expect it to be, which is good. We push it on and it goes up, which is good. We come down through here and we start pushing arrays on here. So it should go up again and up again, and that's all good. And so now when we come through here and do our thing, in theory, we shouldn't really have any collision between these. They're totally non-overlapping, as far as I know. So let's see. So the entities themselves are stored in which array here? So sim region entities, they're in this thing here. And so we should be able to see those flags getting like romped on, I guess. So I'm going to just go ahead and take this pointer and say, I'm going to look at this pointer as an entity, and I'm just going to keep on looking as an entity when we step out of this routine and update those particle systems. So we come down here to, oops, update and render particle systems. I jump down. The flags are set to what? 4. Okay, let's see what happens. Nothing. It was entity 0, right? Guess I can double check. And let's also take a look at what these pointers are. Like, are we anywhere close? And we really aren't. Like, we're not gonna hit it. I don't think. So that didn't get touched, right? So when we come through nsim, oh, okay, so it doesn't happen on the first frame. Bam. That is our problem right there. So, well, that makes it really easy to fix, I suppose, but that is kind of an annoying problem, right? That definitely makes it sound to me like the transient arena concept really just should be done at this level, because, you know, you can't be, I don't know if you can see what happened there. So the fact that this does a begin temporary memory with this arena means that when we end the temporary memory down here, the allocation that we did will go away, right? Which is not what we want. So yeah, I mean, this is a problem. One of the things that we do on Handmade Hero that's not particularly great is we don't really have much in the way of arenas. What I typically do is I usually have an arena per thread for temp stuff and an arena per like thing that's active. So there's a lot less arenas on Handmade Hero than probably I would normally use. And it really doesn't become much of an issue because there isn't that many reasons why it would. But you can see in this circumstance where it kind of is, because it's like, well, at this point, you wish you had a little more flexibility there, because it's not like we need to be that conservative with how many of these things we have, but we then sort of run into these problems where it's like, oh, okay, you know, that was kind of a stupid bug that you don't really need to have, and it's only because you're kind of being more restrictive with these regions than you need to be, which, you know, if we were trying to target an Atari 2600 or something, well, forget that. If we were trying to target a Commodore 64 and we needed all of our memory to be laid out exactly that way, maybe that makes some sense, but that's not actually what we're doing at all. And so, yeah, it's just kind of unnecessary at that point. So I guess what I would say is, the world, where is the actual game mode? So I would say that the mode arena is really the arena, you know, or rather something that tracks with the game mode is where the particle systems really more belong to a certain extent, right? And so I don't know, you know, these things really, I think, want to be a little more formalized here, and I don't know to what extent this ever really wants to be used. You can see that it's kind of largely kind of residual there in handmade.cpp where it's getting used, but I feel like there's just a lot of risk there because now people can't really use that transient arena in that way. But anyway, so I don't know if mode arena would be appropriate here. If we actually do use mode arena in that way, then it probably is, right? Where we push on that stuff. But I don't know how much space we expect to give that normally. So it looks like it takes pretty much all the rest of the permanent storage size. Yeah, I'm going to go ahead and add this here. I think we may change this from Particle System Week to Arena Week because I don't like the way that is, and I think I had it on the list for a while to do to show how to make those things grow dynamically as well, so you wouldn't have to worry about saying how much memory you're going to use ahead of time if you didn't want to. since there's a lot of circumstances in programming nowadays where you don't really have to care. You know, you have, for all intents and purposes, like an infinite amount of memory. The key is just to not use it improperly. And so what you're really more concerned about is the pattern in which you use it and not the amount you use, et cetera, et cetera. And that's, you can actually use the exact same stuff that we use on Handmade Hero, but just if you do some slight modifications to it, you can just have them grow. So it's not really any more constrictive. So I wanted to show how to add that as well, since it's such an easy add-on. So yeah, rather than do anything complicated to fix that tonight, though, I'll just say that we can probably add the mode arena as the place to allocate from, and we'll take a look at that in more detail tomorrow. But yeah. Yeah, so now we're, I think, out of size on this guy, right? Because this guy is really big, and the mode arena can't fit him. But that's actually okay. We can fix that until tomorrow as well. Or not. Does this guy, well, actually, I guess the other thing is, does this guy take all the room in this arena? I don't actually know. Probably. What I can do then is just this. So yeah, so that's fine now, but I don't like having that potential for a lurking bug there for those sorts of things. So I might want to just take some time this week to go through and just like pull out the arena system into something and then finish it up, like add the few things we're going to add to it. And that way we can clean those up a little bit and not have them be things that might be kind of overly obtuse. But yeah. Well, that wasn't too bad to debug, but I definitely wasn't supposed to go that long. So I apologize for the lengthiness. We were 15 minutes over time. I will do brief Q&A if you guys want to, if you have any questions. Greenish, I think you should be searching for max frame since touch. Oh, you're right. Yes, I would agree with that, actually. I don't know why I closed everything down. Yes, you're correct, because min frame since touched, I actually want the oldest. Right. And that makes it so I don't need, I just still wouldn't have needed U32 maximum. Yeah, I agree with that, because if it goes up every time, then I want the one that's been around the longest. Gene Victor, so was the problem that the transient memory vaporized per frame while the particle class used to stay across frame? Yes. The problem was just that the transient arena, it's not really that it vanishes per frame, it's that people in general were just using it as temporary memory, so they do begin and end temps around it. So when things inside there want to allocate from it, it won't work, right? Because whatever they do, they're not gonna, it's not gonna persist. And so since the mode was getting created inside of someone else's render loop, now granted, we probably shouldn't be doing that. Like, you know, it's not like that was really a good thing to happen. So, you know, if you take a look at what's going on in this code that did the actual transition, I don't really remember where that was. Probably in here. What was it that we were looking at there? It was... I don't quite remember. Probably would have been in here. Oops. Yeah, it was this. So if you look at what happens here, you know, we begin the temporary memory for rendering. We do the rendering, and then we release the temporary memory. And so, you know, it makes some sense because it means that we're doing sort of these, we're sort of encapsulating, or blocking out the render to make sure that all the rendering that gets used is not going to go away. But, you know, it's unclear that you really want that to be going in the train arena when these people might be using that train arena for something, or blah, blah, you know, it's kind of, again, it's just unclear when you have this concept of the transient state and who that belongs to. So I just would like to kind of clean that out and say, okay, let's actually have people talk about arenas more clearly, where it's like, here's the memory that's being used for this, and, you know, here's the memory that's being used for this, and we kind of know whose is whose and when these things change. And so that it's like lighter weight to just have arenas that we don't know what their size are, so that we don't really have to care about that if we don't want to. We can just say, hey, we make sure we never use more than 4 gigabytes, but we don't have to pre-parcel out who gets how much of which, at least not at this stage. Snoring Tortoise, not sure if this has been answered on a previous stream, still trying to catch up. When you introduced the threading model, you mentioned that we would want 1 thread per core, but since the OS creates threads for us, so helpful for things like audio, does it matter that we end up with more threads than cores? Well, the answer to that is it would be great if the operating system was written in a way that was good. And on Windows, obviously, it's not, so there's nothing you can do about that. So there is no way to really make it so that you actually get 1 thread per core, which is what you want, because like you say, the operating system will create more. However, just because the operating system will come in and steal time from you when you, even though you didn't want it to, by swapping in other threads that were probably superfluous and unnecessary, that doesn't mean that you don't want to make sure you're not doing that as well. Like, you don't want to make a bad situation worse by having more threads than there are cores in your game, right? You still want to, if you can, make it so that you're well balanced. And yes, unfortunately, you will have to live with the fact that the operating system is going to steal time for you by swapping in these other threads that it has. But there's really nothing you can do about it. If you want, you can try to cross your fingers and hope that maybe the operating system would always just sit on 1 core, and then you can like use all the cores but 1 and then be perfectly balanced. But in reality, it's unclear that that's actually better, because chances are the operating system is going to come in sporadically on any of the cores, and even if it was only coming in sporadically on a single core, it might not use the entire frame time, in which case you still want jobs to be able to execute on that core. So typically, the way I usually look at it is you want to go ahead and take 1 thread per core and have the operating system know that you have 1 thread per core. Please keep it that way so that you're maximally efficient. And then whenever the operating system comes in, okay, you lose some work on that core when it decides to, but that's okay. And by the way, CHI bin, the answer is yes, I no longer use Emacs. I use 4Coder for everything, on stream and off stream now. It is the only text editor that I use now. And it is so much better than Emacs at this point, it's kind of hard to compare the two. Like, it's not a little bit better than my Emacs was, it's like 10 times better than my Emacs was. Like, especially some of these new features that you can do, like this stuff, where I can search for something and have it immediately tell me where everything is. Like, Emacs, you have to remember, like, I'm coming from Emacs. It's like one of the most antiquated editors at this point, right? So I'm not coming from something modern like Sublime, which might have some more reasonable features. I'm coming from Emacs, and Emacs is really pretty broken and very, very slow. And so now, like, that query would have taken many seconds on Emacs because it would have had to spun up a find stir, run the find stir, capture the output, do the thing. ForCoder allows me to just write code that loads all my stuff in memory, and now I can just do a quick query and do that. And you know, I could have done all that stuff in eLisp, but oh my god, programming in eLisp, I never did it because it was awful. So ForCoder is much better now. I made my own like project thing, so now everything can be loaded in memory, and so now like old things that used to be like a grep of files are now just searching for in-memory stuff because I could implement the project stuff that I want, and so I know that all my files are always loaded in the editor and stuff like that, right? The other thing that I point out about ForCoder is for many, many years, and in fact, I even sent Alan when he you know, I didn't even request this feature. It was just something he had mentioned he might want to work on. And when I heard him say he wanted to work on it, I sent him this email thread that was like a decade old or more. When Emacs first added soft returns, I was like, I really wish, you know, Emacs would add the ability to automatically flow text. Because if you think about it, like when you open up a word processor, you don't have to like manually line wrap your lines, right? Like you don't have to indent the first thing of a paragraph and then like manually reflow your paragraphs to like line them up, right? But literally no editor, no matter how modern, that I've ever seen for code does the indenting automatically, right? It should. So for example, there is no known editor that I know of that will take parentheticals like this, and as I type, if I deleted that, just wrap the other two up automatically to it, right? Or and then if I put it back in, flow them back around, right? But that's how word processors have worked for generations. And so I've always wanted that feature, and right now Alan is actually working on that in ForCoder. And if he ships a version of ForCoder that has that working in it, I think that will completely revolutionize code editing. I mean, it would save so much busy work to never have to worry about inserting returns and fussing around with like the white space in your code. Like, it's such a pain in the butt all the time. And yeah, it's great that, you know, ForCoder already and all modern text editors have the ability to auto indent your code when you tell it. But why am I even ever telling it that? And why am I ever even having to decide how long a line is? What if I've got two different machines that have different size monitors? I want to see the line go as long as the line can go and then wrap if it has to wrap. I don't want you to force me to pre-decide how many columns my code is when that's completely irrelevant to the code, right? So when that feature's in ForCoder, which I guess may be as soon as the next version, because Alan's got a lot of it working. He was demoing it this morning, actually, or this afternoon. When that feature is in, I'm kind of thinking ForCoder is almost a must-have. I can't imagine doing editing without that once you have it. It's such an obvious win. I've wanted it forever. No text editor has ever delivered it, or even come close that I've seen. And so if he delivers that, I think it's all over. Like, either all the other editors have to add it, or you have to, or if you're not on ForCoder, I don't know what to tell you. You're a chump. Sorry, you know. So that's going to be kind of amazing if that happens. We'll see. Not to mention all of the editing features that can come from that. Like, then you can just do stuff like, okay, I no longer have to worry about where I am on my white space. Like, I no longer have to worry when I cut and paste this thing that, you know, I'm cut and pasting from the right place on the space or something, because I constantly am doing fiddly things like this to get in there. If you start to virtualize the white space, which is what Alan's doing, you can imagine all these other edit things where it's just like, oh, now it doesn't, this isn't here anymore, right? It's like, I don't have to tell you, oh, I gotta cut between, like, you know, this part of the white space and this other part of the white space. Like, just to give a simple example, right? If I were to say, cut this out like this, right? And then paste it in here, there's an extra piece of white space there. But that's completely irrelevant. Like, there's no reason that I would ever have to tell it that was true. Like, it could just know to not put in more white space there, right? And so there's all these other edit features you could imagine that start to get level up from there as well. So I think the further he goes down that path, the more indispensable for a coder actually would be too, because all of that is busy work. None of it has anything to do with your code. Like, none of the layout you see on the screen right now has anything to do with anything. It could have been automatically done 100% by a pretty printing program. And so the fact that I spend time at all in a text editor entering any of it is obviously wasted. And so I think the more that Vocoder takes over that, the more it would be silly to try and edit in anything else, because now you're just wasting tons of time on stuff that Vocoder will just do for you, you know. So. All right, I'm gonna go, because I gotta go to bed. All right, I'm gonna wrap it up. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the series, you can always pre-order the game on handmadehero.org. It comes with the source code, so you can follow along at home. We have a forum site you can go to if you want to ask questions. We have a Patreon page you can go to if you want to support the video series. And we have a schedule bot you can go to if you would like to know when the series is going to be live. We also have an episode guide you can go to if you want to catch up on old episodes. And, of course, a countdown timer. You can always refresh to see when we're going to be live next, if that's easier for you. That's about it for today. I'll be back here tomorrow, same time, same place. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.